Dear students, in previous video lecture we discussed about the standard equations of hyperbola. What are the standard equations of hyperbola and the coordinates of foci, vertices, length of a lattice rectum of the standard forms of this hyperbola. Now today we are going to discuss exercise this of this hyperbola on hyperbola. Now the first question is find the coordinates of foci, vertices, eccentricity and the length of lattice rectum of the hyperbola. Now the first one is x square upon 16 minus y square upon 9 equals to 1. Here the coefficient of x square is positive. This means that transverse line lies along x-axis or simply the foci lies on x-axis. So we know that the equation of hyperbola with above properties, that is foci and the x-axis, this transverse line on x-axis is x square upon a square minus y square upon b square equals to 1. Comparing this with this equation, we get a square equals to 16, that is a equals to 4, b square is 9, that is b. Also we know that the b square equals to c square minus a square, or c equals to root of a square plus b square. This means that c equals to 5. So we know here a, b and c. Also we know that the equation of foci, coordinates of foci of this ellipse, a hyperbola, that is x square upon a square minus y square upon b square equals to 1 or plus minus c0, which implies that coordinates of the foci of this ellipse is plus minus 5, 0, because c is 5. Similarly, vertices of this general form is a plus minus a0, which implies that the coordinates of vertices of the given hyperbola are plus minus 4, 0. Eccentricity is denoted by E and is defined as C by A, ratio of C by A, that is 5 by 4, while as length of lattice rectum is 2b square upon A. Substituting the value, we get 9 by 2 units. So in this way we find the vertices and the foci of this hyperbola. Now the second one is y square upon 9 minus x square upon 27 equals to 1. Here the coefficient of y square is positive, which implies that transverse line or transverse axis or simply the foci of this hyperbola lies on y-axis. So comparing this with y square upon a square minus x square upon b square equals to 1, a equals to here 3 and b equals to root 27, that is 3 root 3. Now we will find c, which is c this 6, because c equals to root a square plus b square, or b square equals to c root b square equals to c square minus a square. Now the foci of given ellipse, this hyperbola, are 0 plus minus c, that is 0 plus minus 6. Vertices are 0 plus minus a, that is 0 plus minus 3, because both lies on y-axis, that is why the coordinates are 0 plus minus c and 0 plus minus a. Similarly, eccentricity is c by a, that is 2, and length of lattice rectum, that is 2b square upon a, that is 18 units is the length of lattice rectum. Now the third one is 9y square minus 4x square equals to 30. So we will firstly convert this into the general form or the standard form, which is x square upon a square minus y square upon b square equals to 1, or y square upon x square minus x square upon b square equals to 1. So dividing by this 36, because from one side we need 1, that is by dividing it is y square upon 4 minus x square upon 9, which is 1. So we have to compare this with y square upon a square minus x square upon b square equals to 1, which implies that a equals to 2, b equals to 3, c equals to root 13. Now here this ellipse here, in this equation, coefficient of y square is positive, which implies that transverse line or foci lies on y-axis. Hence the coordinates of foci are 0 plus minus c, that is 0 plus minus root 13. Vertices are 0 plus minus a, that is 0 plus minus 2. E equals to c by a, that is root 13 by 2, while L equals to 2b square by a, that is 9. So in this way we find the foci, vertices, this length of lattice rectum, length of this transverse axis or transverse line, that is 2a, while as length of lattice this conjugate axis is 2b. So in this way we find all these features. Now the second question is find the equation with the given conditions. First condition is when vertices are plus minus 2 0, foci are plus minus 3 0. Clearly the coordinates of these foci as well as the vertices, they lies on x-axis, which implies that transverse line lies on x-axis. Hence its equation is of the form of, or should be of the form of, x square upon a square minus y square upon b square equals to 1. Here the vertices of the given ellipse, this hyperbola, are plus minus a0, but the given vertices are plus minus 2 0, which implies that a equals to 2. Foci of this ellipse, this hyperbola, that is this general form, is plus minus c0, that is plus minus 3 0, which implies that c equals to 3. We know that b equals to root c square minus a square, that is root 5. Hence substituting a equals to 2, b equals to root 5, and given we get x square upon 4 minus y square upon 5, that is 1. So this is the required equation of hyperbola with vertices plus minus 2 0 and the foci are plus minus 3 0. Now the second one is foci plus minus 5 0, that is we have to find the equation of hyperbola with the foci, with the coordinates of foci plus minus 5 0 and length of transverse axis is 8. Here the coordinates of foci are plus minus 5 0, which implies that the foci or the vertices or the transverse line is along x-axis. So its equation is of the form of x square upon a square minus y square upon b square equals to 1, because we know that the general form of this hyperbola whose coordinate is foci or the transverse line lies on x-axis is this. Here this coordinates of foci, or here length of this transverse axis is 8, which implies that 2a equals to 8, because 2a is the length of transverse axis, which implies that a equals to 4. Also the foci are plus minus 5 0, but for general form it is plus minus c 0, which implies that c equals to 5. Also b equals to root c square minus a square, which implies that b equals to 3. Hence substituting the value, we simply get x square 16 minus y square upon 9 equals to 1 is the required equation of such parabola, this hyperbola. Now the vertices, question number 3, vertices are plus minus 7 0 and eccentricity is 4 upon 3. Clearly its equation is of the form of x square a square minus y square b square equals to 1, because vertices lies on x-axis. That is why we have to take the coefficient of x square to be positive, which implies that when vertices are plus minus 7 0, which implies that a equals to 7, e equals to 4 by 3, but e equals to c by a, which implies that from this c equals to 28 upon 3. Also c square equals to a square plus b square, which implies that b square equals to 343 upon 9. Hence substituting a and b in this form, that is x square upon a square minus y square upon b square equals to 1, we get x square upon 49 minus y square upon 343 upon 9 equals to 1, or x square upon 49 minus 9y square upon 343 equals to 1. So this is the required equation of this hyperbola whose vertices are plus minus 7 0 and eccentricity is 4 by 3. So in this way we completed this whole this conic section, because this hyperbola is the last conic section which we have to discuss in this class. So inshallah from tomorrow onwards we will discuss another chapter, that is sequence and series, which is one of the most important chapter. So thank you.